Hello guys, welcome to our today's lesson. We are going to look at the equation of the normal to the curve. In our previous discussion, we had looked at the equation of a tangent. We were able to learn a lot from that presentation. Now today, we want to look at the equation of the normal to the curve. And before we get into the equation, allow me illustrate where the tangent is and where the normal line is using the curve. This is the curve that we have, and in our previous discussion I said that this line that touches the one part or part of the curve is known as the tangent. This is what we call the tangent. Now there is another line that is like this. This line is what we call the normal line. And then, of course, this is our curve. This is the curve that we have. Now, in this case, we are going to find the equation of the normal to the curve, this line to this curve here. And in this case, we are going to meet a formula that says when we have the when we have got the gradient for the tangent, you multiply by the gradient for the normal. This one will give you -1. This one will give you -1. So in our equation, the equation we are going to form, we are going to use the gradient for the normal. Unlike in our previous presentation, we used the gradient for the tangent. So let us move to the solution. We are going to run this question through the steps that we followed previously on writing the equation of a tangent. So we are going to find the derivative dy over dx. We are going to find the derivative, that is dy over dx, the derivative of the function. In this case, our function is in fact yx is equals to -4. Now we can rewrite this. Yx is equals to -4. We can rewrite this by saying y is equals to -4. Then we divide by what? We divide by x. We want to make y the subject of the formula. We can as well write this and say this is the same as saying y is equals to -4. Then this one is x raised to -1. Now let us find the derivative. Dy dx is equals to -1. We multiply by -4. Then this one, x -1. Then we less by 1 by 1. We are going to have 4x raised to -2. This is our dy dx. We can as well rewrite this and say this is the same as 4 over x raised to power 2. Now let's go ahead and find the gradient. We can find the gradient. The gradient is given by 4 over x squared. We are going to substitute the x value into what we have here, and the x value is in fact -1. So we bring that -1 and substitute in this x. So we are going to have 4 over -1 squared. This one will give us what? 4. So we have got m tangent. The m tangent is in fact 4. Now we know that m tangent times m normal, this one will give us -1. So let us find the m normal. So we have 4 m tangent times m normal. We do not have the gradient for the normal is equals to -1. We can easily find the gradient for the normal by dividing through by 4. So m normal is equals to negative a quarter. Now that we have negative a quarter, we can proceed and say, let us use this part. I don't want to turn this paper. Let us use this part and say that now that our m normal is equals to negative 1 over 4, we can say y minus y1 is equals to m. Then we multiply by x minus x1. In this case, our m is going to be the m normal that we calculated. So we have y minus our y1 is now, this is our x1 and this is our y1. So our y1 is in fact 4, our y1 is 4, is equals to negative 1 over 4. We multiply by x minus, what is our x1? x1 is minus 1. So minus minus, it is plus what? Plus 1. This is plus 1. This one is plus 1. Plus 1. Now, we can easily say that y is equals to negative 1 over 4x, then minus 1 over 4. Then this one will cross the equal signs, then it will become positive 4. Now, our final answer will be y is equals to 1 over 4x, then plus 15 over 4, 15 over 4. And this is the equation for the normal, and this is the equation for the normal. This topic is, it cuts across for high school students and university students. So let's continue watching and sharing this video. Subscribe and let us meet in the next lesson. Thank you so much. I'm looking forward to meeting you in our next presentation. Bye bye.